Facade retention, the removal and renewal of a building's innards, its walls, columns and floors, while retaining its original front or outer walls, plays an important role in preserving the architectural character and historic fabric of many of our city centres.
But it can be a complex and expensive exercise. In this programme, we're going to take a look at some of the technical aspects of facade retention through the outline design sequence, namely appraisal of facade construction and condition, relationship to the new build, the temporary support structure, and the sequence of demolition and rebuild.
And here to talk us through things is Peter Ross, structural engineer and consultant to Arup. Peter was also a co-author of the Syria Guide on Retention of Masonry Facades. Welcome, Peter. Thanks for coming in.
Thank you, Martin.
When would you look to retain a facade?
Well, let's suppose that we have a client who has a building that he really wants to redevelop, but the building is listed or perhaps in a conservation area, and the permission will not be necessarily given for the total demolition. But the facade, the public face of the building, obviously has a townscape value. So the retention of the facade, retaining the townscape value, but with a redevelopment behind, may be a compromise way forward.
Now, what we're going to do, Peter, in this programme is look through a series of photographs and drawings drawn by your own fair hand, for which we're very grateful, to illustrate what we're going to be talking about. So let's just have a look at our first image. Now, what's this, Peter? Talk us through this.
Right, I want you to come to the north of England with me. We're here in Grey Street, Newcastle on Tyne, and the street curves and rises up to Grey's Monument in the centre, Theatre Royal on the right, and the entire street is lined with firm, robust classical architecture right from top to bottom. And the individual buildings are given variety and form because every alternate building has giant Corinthian columns attached.
This is a lovely series of structures. Is this facade retention something we would consider only for listed buildings?
The facade would have to have some basic quality to consider retaining it at all. But a listed building or a conservation area, it might give a client a way forward when he would otherwise not have the facility to redevelop his property.
What sort of facades are we mainly talking about?
Well, in the main, facades dating from the 18th to the early 20th century. The 18th century would have mainly load-bearing masonry walls, and towards the end of the 19th century and into the 20th century we might have steel frames.
And we've got a few examples here.
Yes.
Where
so
are these?
Here is this first one is a robust mid-Victorian building. It's a corner building, which makes it more important from the townscape point of view. It's probably masonry faced because all of the buildings that we see from the 18th century on are only faced in masonry, all backed up in brick for obvious economic reasons. The second one that we see here is obviously early 20th century. It's Art Deco, but there's some rather spindly columns at ground level, and so it's likely that this had been underpinned as a billboard facade, and we'll come to that later. There's some lovely details on the facade. Elephants in Kent, how about that? But it's that sort of detail which makes the facade valuable and worth saving.
Okay, let's move on and have a look at the first phase of the outline design sequence, the facade appraisal.
Thorough investigation of the facade and adjoining construction is an essential part of a successful facade retention scheme and should incorporate an examination of the form of construction, stability, both vertical and horizontal, roof details, bay windows, possible existing alterations on the ground floor, basements, and finally the feasibility of detaching the facade from the main structure.
Okay, Peter, let's pick out a few things from that list. What should we know about walls?
Well, the first thing to say is, of course, that a thorough survey for a facade retention is vital. the facade is going to undergo the equivalent of a transplant, and it must be robust enough to stand for a while unsupported. So here we have possible wall forms. On the left we can see a solid through bonded brick wall. This would be ideal. We rarely get it, but it's the ideal. It would be very robust. In the centre we see the more normal facade, which is stone faced and then brick backed. So the question of the bond between the two starts to become more important. I've imagined that this building has timber floors. All those timber joists have got to come out, and they leave a row of gap teeth, so to speak, in the wall. And on the right is what one might say is a wall of two halves. That's an outer leaf of stone and an inner leaf of brick. And if they are not well bonded together, then this is not a robust wall.
And we've got a few photographs of what you're talking about here.
Yes. Now this is not actually facade retention. The photograph is there just to remind you that bricklayers on the whole do a better job when they think their work is going to be seen than when it is not going to be seen. So the inside of a wall is sometimes not very pleasant to look at. The next photograph
that's a cut through a solid wall, it looks like to me.
That is correct. It is not as bad as it looks, because when you look carefully there are headers, that is bricks set across the wall, coming from each leaf into the middle. So it's probably has a reasonable integrity. And the last photograph on the right shows a facade probably of the late 19th century with steel in it, steel frame. And this of course is a tremendous help, because it really helps to stabilise the wall in the temporary state, as long of course as there isn't more than just surface rust on the steel.
So that's walls. What about roofs?
Well, here are some of the roof situations that one might find. On the left is an overhanging eaves. Now naturally that roof will have to be dismantled because it's really part of the building rather than the facade, but it would have to be recorded, because it would probably have to be replicated as part of the planning approval to replace the facade. In the centre is, I've imagined, a pitch roof but with an upstand parapet. This is useful because the upstand parapet conceals the roof from ground level view, and there is more flexibility in the redesign. And on the right hand side is a rather ambitious cornice. Now then, one must be careful about overhanging cornices. How are they stabilised? Are they tied down, or is it just the weight of the parapet?
One would assume those are quite common features in facades that are retained.
They are, indeed. And again, the stability and the way it is all held together in part of a survey. And some part of this survey must be investigative. A visual survey might not be enough to tell you about the hidden details.
And there's one more type of roof, a typical dormer.
Yes, dormers are awkward. You see, although they appear as the front elevation of the building, they are really part of the structure, the main structure behind which is going to be demolished. So they will probably either have to be carefully dismantled for re-erection or recorded for a facsimile to be rebuilt.
So you've really got to have a thorough understanding of how the building works and the alterations that have been undertaken on that building.
Absolutely.
Okay, what about windows?
Well,
here's a typical window.
The windows are important because they are very much the character, that they express the character of the time of the building. And the almost ubiquitous window through the period we've looked at is the sash window. The early ones with small lights, the later ones with larger lights. And they have quite a complex relationship with the wall. If we look at these cross sections, there's the head detail. We often have some soldier bricks, perhaps even arched, above, and inside there will probably be a lintel of timber. and it would be wise to replace the timber with probably some in situ or precast concrete. The windows themselves would also have to be studied and recorded. It's very unlikely that they're going to be in good enough condition just to be replaced, so they're probably going to have to be replicated. And since a facade retention essentially means that the building behind is going to be a new building, then probably the building regulations of today will have to be satisfied. And hence the question of the insulation value of the windows would come up.
And here's a bay window as well, typical bay window. Yes,
this is a bay window which projects. And you see I've drawn it as on a cantilevered steel. The inside of the cantilever is obviously going to be cut off. And a bay like this, one might have to give additional vertical support from the supporting structure that we're going to talk about a little bit later.
So a thorough understanding of the forms and materials used, and one should expect the unexpected.
I think so. Here are the usual ones occur at ground floor level. For obvious reasons, the ground floors of older buildings have been altered more than the superstructure. As
we saw in the bank.
Exactly. And here is what is called a billboard facade. I think you can understand that. The ground floor has been taken out completely, a lintel put in on posts. Now it looks very obvious in this drawing, but what generally happens is that then this is mocked up with a pseudo facade and the structure might not be clear. But a billboard facade is obviously very unstable when you take the building away from it, and special care would have to be taken. And the other surprise might be the existence of pavements. Now,
basements.
Indeed, even basements, Martin. Basements are often found under the pavements, and they were in fact a method for delivering coal. There would be a coal hole in the pavement and a door into the house. Now, over the course of time, coal is hardly ever delivered to properties these days, and so the pavement has smoothed over the coal hole and the door may have been blocked up from inside. And these basements are sometimes a genuine surprise even to the owners of the building. Now, this would be an embarrassment if you were trying to stand a facade retention structure on what is virtually a brick vault.
Okay, right, so you've made it very clear there what to expect in that sort of situation. What about the feasibility of detaching the facade from the main structure? Tell us a little bit about that.
Well, there are two main points. The first is that one would have to be convinced that the facade could continue to carry its own weight to the ground when the building behind is removed. The second point would be that all the lines of cut, let's say cross walls, the floors, would have to be examined to ensure that that could be done without damage to the facade wall.
Okay, we'll come to a worked example in a moment, but let's have a look now at the factors influencing the relationship to the new build.
The nature of the facade to be retained will significantly affect the design of the new structure, especially considerations such as roof slope. For example, will this allow extra floors in the new development? Window locations and floor levels, which of course are difficult to change, but can both be solved by the possible addition of an atrium.
Peter, explain for us how the roof slope can influence things.
Well, to illustrate that, let's have a look at Southampton Road. And this is a development in central London with high property prices. On the left is the building as it was, and on the right is the new building. And the volume of build is outlined in colour, and you can see that the scheme has resulted in almost doubling the volume of the building, which is one of the real drivers for a facade retention project. Now we come to the stabilisation of the facade wall. The reason we've done this is that we have allowed the floors in the new build to get out of sync with their old positions. And this would mean that they cut right across the windows. So we now have to stabilise the atrium wall, which is now spanning from first floor to fourth floor. And this is done, as you can see in this photograph, with a steel plate bolted to the inside of the wall, and on the outside with a tension rod. And the tension is put in the rod by a large spring, which you can see in this photograph here. A little bit of high tech in the centre of London.
And what about this one?
That's a photograph of the plate bolted to the inside of the wall.
Okay, so it's just fairly neat solutions there.
Yes, I think so. The client gets the best of both worlds.
Okay, let's have a look now at our temporary support structure.
The temporary facade retention structure may be located external to the facade, which is relatively easy to construct if there is generous space, but this is often restricted to pavement width. Alternatively, the retention structure may be constructed behind the facade. This is more difficult to erect as it pierces the existing and new structures. It's also important to consider fixings. The facade is usually restrained by clamping to both faces between wailings strapped through openings. And finally, the temporary facade retention structure should be justified under wind loading.
Now, an external facade retention structure allows plenty of working inside, but there may be issues with that.
That's right. It is true that for most facade retention schemes attempt to stabilise on the outside because of the freedom it gives the work inside. So in my first drawing here, I've assumed that there is a plenty of space outside the facade, and that would allow us to build our cheapest form of stabilising structure, which is simply done in scaffold. However, scaffold is fairly lightweight, and you would need a space of about half the height to get adequate rigidity. And in
Pavements.
yes, exactly. It's rare that you're going to have that sort of luxury. You would therefore have to change to a more bespoke form of facade retention, which would be shown here on this sketch. Let's have a look at the left side. And here we see a facade which is stabilised by a framework. Here we have a facade retention system which is outside the building, but it is limited by the curb, by the back of pavement. And you'll see that there are several problems here. The local authorities insisted that pedestrian right of passage has been maintained, and this is a very constricted site, and the contractor has nowhere else to put his offices. So the first two floors of this facade retention scheme are in fact virandiles to allow those two things to happen, and then above that level it's triangulated. On the right hand side we see the more difficult option, which is to construct a retention structure within the building profile. And this is very difficult because, of course, you have to punch holes through the existing floors and work out some sort of triangulation system which not only coordinates with the existing structure before its demolition, but also makes sense in terms of the new structure. I've assumed in this case that this was a late 19th century building, and there is a steel stanchion in the external wall. And I've welded onto it the rest of the triangulated stabilising frame.
Okay, let's have a look at some connections between the facade and the retaining structure. You've got a few photographs here.
Yes, that's right. Now here's another, this is the Middlesex Hospital, again in central London. This is a very long facade, not particularly high, and we can see on the right hand side there that it is in fact essentially a purpose-made structure in steel sections. If we now look at a detail, we can see that the frames are a series of vertical triangulated cantilevers, in fact. And in order to connect to the wall, and in the next photograph we see horizontal wailings, and these are packed off the wall with timber, and tension rods go from the wailings through the windows to a similar wailing at the back of the wall.
And I'm wondering what's happening on the other side.
Well, we can go round and have a look. And there you can see the twin wailing, which matches the one on the outside. The ties going through the windows, which are the most obvious place to grip a facade. And the whole thing is sheeted out for protection until the final works are done.
And what about wind loading?
Well, it is, these days, most facades are sheeted out completely for health and safety reasons. So you have to design it for a solid facade, and wind loads are significant. And the difficulty is not so much to provide the compression load on the cantilever truss as the tension load. And this often has to be provided by large blocks of concrete as Kent ledges, or in fact worked into tension piles.
Okay, let's move on and have a look at the sequence of demolition and rebuild.
In the demolition and rebuilding operations, there are 4 key phases. First, erection of temporary support frame, then making connections to the wall. Next, demolition of the redundant existing structure. And finally, construction of a new structure.
Let's talk about the demolition. What are the constraints on that process?
The most usual one is getting all the demolition material off the site. It's pretty obvious that it's very difficult to take it out through the facade you just retained. And so it is to be hoped, in fact, if it have to be taken into account in the planning, that there are other routes off the site.
And the rebuild process, let's talk about that.
Well, the same, in a sense, the same question applies in that a lot of material now has to be reintroduced onto the site, probably with some craneage access to, in fact, get it all back into position. And the facade is always a difficult constraint because it is there and has to be protected. You can perhaps now see the logic of putting the facade retention structure on the outside of the site rather than on the inside.
And what about these connections that allow vertical movement?
Well, one would have to look at the facade and decide how much movement it's likely to undergo. If we were doing a small retention in height, let's say 2 to 3 stories, in robust masonry, and then we were putting a new steel frame inside, then the movement between the two would probably be quite small and one could probably ignore it. But if, for instance, we had a higher facade than that, we might have to look at the question of allowing movements between the facade and the new structure. And I've drawn a couple of them here. So if we look at the 2 drawings on the left-hand side...
This is a plan and a section.
That's right. At the top is a plan. And there we have a new stanchion inside the existing facade wall. And I bolted cleats to the wall to provide a horizontal restraint, but at the same time some degree of vertical movement. These movements are very small, but at the same time one should allow for them. On the right hand side is the same sort of arrangement for a concrete slab. And again the same principle follows, that the restraints provide a horizontal tie to the wall while allowing a small amount of vertical movement.
And you've got a through fixing here as well.
Well, that would be that sometimes you can do that. If, let's imagine that the external facade is rendered, then one could put bolts in quite easily, and the new render could conceal the whole thing and it would be hidden from sight. So this may be, there are a vocabulary of connections of this kind, all using the same principles.
As we said at the start of the programme, this is a complex and can be an expensive exercise. What would your final words to the engineer be before embarking on such an exercise? Without
being too downbeat about it, to recognise the risks and to do a very thorough survey, both visual survey and investigative work. And then the second thing is, it is really up to the engineer to lay out a clear method statement. He has to provide one way of carrying out the project. If the contractor can improve on that, that's fine. But if there is no way ahead, if problems haven't been solved, then a facade retention can be a very big embarrassment.
Well, Peter, thank you very much for coming into the studio and talking us through this very interesting exercise, and thank you also for bringing in your photographs and drawings. It's made for a very interesting session.
Thank you, Ron. It's a pleasure.
As always, there's more in the study notes, so do take a look. However, for now, from us both in the studio, goodbye.